All right, hello. My name is Michael Starbuck, and this is my project for the second data science practicum at Regis University. I decided to uh, do a project on predicting the winner of NHL games based on the box score statistics collected from each game. In the NHL, the National Hockey League, there have been over 10,000 games played since the 2008-2009 season. And for each of those games, a box score is recorded. Used to be in the newspaper every day. Now it's online or wherever you see your hockey information. The box score is always um, displayed for each game, and some standard statistics, including hits and shots on goal and power play opportunities. Um, those are all standard statistics that are included for each game. And I decided to see if those stats are really useful, if they're really telling the true story of the game. And if you can just look at those statistics and determine who won the game. So looking for data, I found that the NHL.com website has a very thorough stats page. The data is very clean. They had a 6-year project that just rolled out in the past year, and what they did was they took old uh, stats that were kept only on paper, and they um, logged them all into their database, and they made sure that there were no missing stats for any game ever. So uh, the stats page was a really a good find for me for this project. So I went to the website and scraped the data from their JSON page, and I decided to look at only regular season games. So I did not include the playoffs, and I looked at only the home games. So I didn't get two home and away stats for each game. Uh, and so after the initial cleaning, I joined multiple things together, ended up with 11,000 rows. So there were 11,831 games and 31 different variables or statistics, and including the class variable, which is wins. So in scraping the data, I went to the NHL.com and used a from JSON package to scrape the data in R and brought that in. And the way they had it broken out, I had to pull in hits and penalties and shots and face-offs all separate. And then there were some statistics that were duplicated, so I had to cut out some and then join them all together. And like I said, I ended up with 30 different variables plus that class variable, which is wins. So in the initial exploration of the data, I found that there were no missing values, just as advertised. And the correlation plot showed that there were some correlations between columns, but it was really just face-off win percentage can be derived from face-offs won and face-offs lost. So things that could be derived from other columns just needed to be eliminated. Other than that, we didn't have much correlation between the different variables. A little over half of the rows had the class of 1, which meant was a win for the home team. So this showed a slight advantage for home teams, but really not not significant. So I decided to look at the team name variable to see if I wanted to keep that in my data or just exclude it. And I immediately found that there were some definite outliers in the data. And what I found was that the Arizona Coyotes changed to the Phoenix Coyotes. They didn't move, but they just changed their name. And then the Atlanta Thrashers moved to Winnipeg and became the Jets. So since they were the same franchise, basically the same team that moved from one city to another, or um, in the case of Arizona and Phoenix, just changed the name. I decided to change the name displayed in the data to match the current name. So all of the ARI was changed to PHX, and all of the ATL was changed to WPG. The Vegas Knights are a team that were brand new in 2017-2018 season. So they've only played one season in this data. So they are the lone outlier. And other than that, there's no significant differences in the wins between the clubs. In exploring the date variable, I didn't really want to keep the exact date and time of each game in the data, but I thought it might be interesting to see if there are changes throughout the year. So at first I grouped the months into early, late, and mid-season. Trying to see if there was significant difference um, in the win percentage for certain parts of the season, and I didn't find much variance there. So then I tried just grouping it by the month and not the special categories. And as you can see here, I found some variation here in February, about 52.8% win percentage, all the way up to 56.8 in December. So there is quite the variability in here. So I decided to keep the month variable and plug that into my model. So the next step is actually building the models. There are two methods that I will be utilizing: the support vector machine from the E1071 package in R, and a neural network from the NNet package. And the best performing model, I'm going to build two initial models with sort of some default parameters, and then the best performing model I will select, and then fine tune some parameters and see if I can improve the performance from there. I decided accuracy will be used to determine the performance because I'm not really concerned about a false positive or a false negative. I really just want to see if I can predict a win or not. So accuracy is really going to be the appropriate measure here. And for my training and testing split, I did a 70-30 split. So on to building the SVM model. I used a radial kernel and gamma of 1 over the number of rows, and ended up with a accuracy rate of 80.82%, which is actually better than I expected. I initially thought I might have to add some of the more advanced analytic statistics that aren't included in the standard box scores to get stat or accuracy like this. So I was pleased to find that I was able to get 80%. So also excited to see if maybe the neural network model or after fine tuning some parameters I can get even higher. So after that, started building the neural network. Before I built this model, I converted all the data to numeric, and I normalized the data and made a size 4 network. And then you can see the remainder of the default parameters that I put here. I'm calling them default just because they were my first test here. I found a mean square error of 0.128, and the accuracy that I found was actually a little bit higher than the support vector at 81.14%. Based on that, I decided to select this model and go on and fine tune this one. So in the optimization of the model, I decreased and increased and played around with each of the parameters. And as you can see here in the list of all of the changes that I made, I was not able to get any higher than uh, the initial accuracy, and it really didn't change much. Increasing the size was the thing that changed the accuracy the most, and it decreased the accuracy. That was increasing to a size of 10, just to see what would happen. And increasing the max iterations just to make sure that it converges didn't help at all. Really, there's no significant difference in really any of these, but decided to just stick with my initial parameter set. So now that I know the parameter setup that I want, I decided to play around and see if adding or removing variables would change that accuracy. And initially on my neural network model, I did not include the team name. And so I decided to add the team name. I went hot and coded the team names and added it in there. And as you can see, I have an 80.1% accuracy rate, which is slightly lower. And then I took that out and removed the months variable as well, and came up with 80.6, again, slightly lower. So removing a variable, it didn't surprise me that it was slightly lower accuracy, removing the months, but adding the team names in, decreasing the accuracy. I thought that for sure I'd get a little bit of a lift there, but did not see that. So after this, I decided which statistic is really the most important in this model, and which ones are really not important, can we kind of ignore. So I found a blog post on our bloggers, and this Matthew Beck has built a function that I was able to plug in my neural network model into this function, and it gave me this nice graph. As you can see, the uh, labels at the bottom are difficult to read, but I was able to print out the data, and so I could see what each of these were. And I found that the highest importance on the variables was shooting percentage, game misconduct penalties, and shots for, so that shots taken. And the lowest importance was face-offs lost, game month, and hits. So removing that game month obviously lowered the accuracy a little bit, but not much. And so that's kind of reflected here on the low importance. What I found was very interesting to me was the game misconduct and the match penalties variables had a positive correlation. If a team has more game misconducts, they're more likely to win, which is very surprising to me, because that means a player on your team is gone for the game. They've been kicked out and cannot participate the rest of the game. So it puts your team at a disadvantage. So it's surprising to me that had a positive correlation. So in conclusion, I found that the box score statistics for NHL games really do tell the story of the game. You can look at those statistics and see who won the game. What was a little bit surprising to me also was face-offs won and lost has very little impact on determining the winner. There's always a key face-off at the end of the game that somebody needs to win this face-off to control the puck, to have a chance to score, or to keep the other team from scoring. So I thought that the face-offs would have more of an impact, but they had low importance. Penalties and power plays do have a big role in determining the outcome. This was not surprising, because having the power play gives the team the advantage in scoring. So that was not surprising. And then I think other advanced statistics may help increase the accuracy, but because of the higher than expected accuracy initially, I decided not to explore the advanced statistics. So that may be further research. And you can see my references here that I used. I mentioned Matthew Beck in his our blogger's post. I also used a source for learning how to scrape from the web. This was the first time I had scraped data from the web, so it went nice and easy. And like I said, NHL.com/stats was a very, very useful site source for the data. And that's all I have for today. So thank you for listening, and